All right, so get this. We're diving into some pretty cutting-edge AI research today.
Oh, yeah.
Yeah, we're going to be looking at this paper about large language models.
LLMs.
LLMs,
Those
exactly.
things are everywhere these days.
You've probably heard about them. They're like the brains behind all these chatbots, text generators.
All that, yeah.
But this deep dive, it's not about all that. This one gets into how we can make LLMs even better at planning.
Planning.
Planning. Like, really good at planning.
That's interesting.
Yeah, it's about taking those LLMs beyond just like, understanding and generating text.
Right.
This research wants to know how we can train them to solve problems.
Like real problems.
Real problems, the kind that need, step-by-step thinking, strategic planning.
Like what humans do.
Exactly, like humans.
I like that.
So think about solving a Rubik's Cube.
Okay.
Or maybe those brain teaser puzzles, the ones where you have to make the number 24 using 4 other numbers.
Oh, yeah, I love those.
Right. That's the kind of stuff that this research is getting into.
So they're using LLMs to solve those kinds of problems.
That's the idea.
I'm curious, what kind of examples are they using in the paper?
Oh, they've got some good ones.
Okay, like what?
Well, you've got Block Swirl.
Block swirl.
Yeah, it's where you have to move these blocks around to get a specific arrangement.
Okay, I can see that.
Then there's the game of 24, the one I just mentioned.
Yeah.
And get this, they're even looking at how to solve a Rubik's Cube.
Wow, with an LLM?
With an LLM, it's wild.
I mean, that can't be easy.
No, it's definitely not.
So how does an LLM even approach something like that?
Well, take Block Swirl, for example. It sounds simple.
Right? Yeah, move some blocks around.
But for an LLM, it has to actually understand where those blocks are in space.
Right, it needs to see them.
It needs to figure out what happens when it moves one block. And then it has to come up with a whole sequence of steps to get to that final arrangement.
Oh, so it's not just about moving blocks randomly?
No, not at all.
There's actual logic involved.
It's complex for sure.
I can see that.
And that's where the challenge comes in. You see, existing methods for getting LLMs to plan,
Yeah.
they can be kind of unreliable.
Unreliable.
Or they could be really computationally expensive.
What do you mean expensive?
Like it take a ton of processing power to run.
Oh, I see.
So some methods, what they do is they rely on the LLM to check its own work.
To check its own work.
Yeah, basically.
But isn't that a problem?
It can be, yeah. I mean, let's be honest, it's not always the most reliable approach.
Right. We all make mistakes.
And then there are other methods.
Yeah.
They involve training a whole other separate model.
A separate model.
Yeah, just to guide the LLM.
That seems like a lot of work.
It is. It takes a lot of data, a lot of computing power.
Resource intensive, for sure.
Very much so.
So is this paper proposing a new method?
That's where this new research comes in.
Okay.
They've developed this method. They call it AutoHD.
AutoHD.
AutoHD. And the goal is to address those limitations.
The ones we talked about, the reliability and the expense.
Head on.
Yep. Interesting. So what's the secret to AutoHD then?
All right, so let's unpack AutoHD a bit.
Okay, I'm all ears.
AutoHD is all about getting LLMs to generate these things called heuristic functions.
Heuristic functions.
Heuristic functions, yeah. Imagine them as like rules of thumb.
Rules of thumb.
Rules of thumb, shortcuts that the LLM can use.
Just cuts for what?
Shortcuts to quickly evaluate how good a particular step is in a plan.
Oh, so instead of trying every single possible move,
Right.
the LLM can use these heuristics to narrow down its options.
Exactly, and then focus on the most promising paths.
That makes sense.
So the whole planning process becomes way more efficient.
I see.
And here's where it gets really interesting.
Okay, hit me.
These heuristic functions, they're not just like abstract ideas or anything.
Right.
They're actually written as Python code.
Wait, what? Python code?
Python code, yeah. You can actually see the logic that the LLM is using.
Wow, that's pretty cool.
Yeah, it's a huge win for transparency in AI,
Peak time.
So the LLM is basically writing its own code.
To solve these problems.
It's pretty amazing, right?
That's why.
And it's not just spitting out code blindly either.
Okay, so what's it doing then?
It can actually generate both a natural language description of the heuristic.
A description.
A description, yeah, like it's explaining it.
Wow.
And the Python code to actually implement it.
So it's describing what it's doing and then writing the code to do it.
It's like the LLM is actually explaining its thought process to us.
That's pretty incredible. It is, right?
I need an example, though. How would this work with something like Bloxworld?
All right, so let's say the goal in Bloxworld is to get all the blocks stacked in a specific order.
Okay, I'm picturing it.
Now, the LLM using AutoHD, it might come up with this heuristic that considers how many blocks are out of place.
Out of place.
Yeah, like not in the right spot.
Right, right.
And in D, how far away those misplaced blocks are from their target position.
I see, I see. So a block that's way off in the corner, and it needs to be at the bottom of the stack,
Yeah.
that would get a lower score
A lower score.
than a block that's just one spot away from where it should be.
Okay, so the further away it is, the lower the score.
Exactly.
So that score, that's what guides the LLM.
Right, that score from the heuristic function, that's what guides the LLM search process.
It knows to prioritize those higher scoring moves.
It'll prioritize the moves that bring those high-scoring blocks closer to where they need to be.
That's clever. And I see the paper mentions they use 2 different search algorithms.
Yeah, greedy breadth-first search and a theorist.
Do they both use the heuristics in the same way?
That's a good question. They both use them, but in different ways.
How so?
Think of greedy breadth-first search as like the explorer, you know?
The Explorer.
It likes to check out all the nearby options first,
Okay.
using the heuristics to decide which of those neighboring moves seem the most promising.
So it's looking at what's right around it.
Right, and then you've got a search. It's a bit more strategic.
Strategic how?
It uses the heuristics to estimate the cost of different paths,
Cost.
like how many moves it might take, how difficult the path is,
Right, right.
and it tries to find the most efficient route to the goal.
So it's planning ahead more?
More long-term thinking, yeah.
So it sounds like both algorithms benefit from having those heuristics to guide their search, but they each have their own way of using that information.
Exactly, and what's really cool is that the paper found that both algorithms, when combined with AutoHD, they significantly outperformed other methods that didn't use these smart heuristics.
Oh, wow. So AutoHD is making a real difference.
A big difference.
This is really fascinating, but I'm curious about something.
What's that?
You mentioned heuristic evolution earlier.
Yes.
Can you tell me more about that?
Okay, so the LLM generates these heuristic functions, right?
Right.
But they're not set in stone.
They're not.
No. AutoHD has this process. It actually refines these heuristics over multiple generations.
Refines them. What do you mean?
It's like the LLM comes up with a first draft of the heuristics, tests them out,
Okay.
sees what works, what doesn't.
Learns from its mistakes.
Exactly, and then uses that feedback to improve them.
So it's kind of like survival of the fittest, but for heuristics.
Exactly.
The LLM is learning to become a better planner.
By evolving its own rules of thumb. Yeah.
So not only is it generating the code for these heuristics,
Right.
it's figuring out how to make them better over time.
That's what's so incredible about it.
I can't believe it.
It's mind-blowing stuff, right?
So did it actually work, though?
Did this whole AutoHD approach actually lead to better planning?
Yeah, that's the big question.
That's what we're going to get into next. The paper presents some really compelling results from their experiments.
From the experiments.
On those benchmark tasks, we talked about Block's World, the Game of 24, Rubik's Cube.
Hey.
And let me tell you, the findings are pretty remarkable.
All right, I'm hooked. Let's get to those results.
Let's do it. Okay, so drum roll, please. What did the researchers find when they put AutoHD to the test?
Well, right off the bat, AutoHD just crushed it.
Crushed it.
It consistently outperformed all the other planning methods they compared it to.
Like by a lot.
We're talking significantly better performance across the board.
Across the board.
All 3 tasks, Block's World, Game of 24, Rubik's Cube.
So it wasn't just a fluke.
No.
AutoHD really proved that it's a better way to do LLM planning.
It really did.
That's huge.
Yeah.
Okay, but did it only work with like certain kinds of LLMs?
What do you mean?
Like, did you need a massive, super powerful LLM to get these results?
That's a good question, and the answer is no.
No.
Another remarkable thing they found was that AutoHD worked well across a whole variety of LLMs.
Even the smaller ones.
Even the smaller ones.
So you don't need to have access to like the biggest, most expensive AI models to benefit from this approach.
Exactly.
That makes this technology a lot more accessible, which is really exciting.
Definitely. It opens up so many possibilities.
For sure. You could use AutoHD in a wider range of applications, maybe even on devices with limited computing power.
Potentially. Yeah.
Okay, so AutoHD works well across different LLMs. It consistently outperforms other methods.
Right.
Were there any other, like, standout findings from these experiments?
Oh, yeah, for sure.
Like what?
Remember how we talked about the Game of 24?
The one with the numbers?
Yeah, where you got to use 4 numbers to make 24.
Right, right.
Well, one of the really interesting things they found was that AutoHD was able to come up with multiple solutions.
Multiple solutions.
to those puzzles.
So it wasn't just finding one right answer.
Nope.
It was finding several different ways to get to 24.
It was, like, exploring the problem space.
So Auto HD is not just about finding a solution.
It's more than that.
It's about exploring different possibilities, coming up with creative alternatives.
Exactly.
That's pretty impressive. It really sounds like this approach is bringing something new to LLM planning.
I think so, yeah.
And we can't forget about that heuristic evolution process we talked about.
Oh, right, right.
The researchers found that giving Auto HD more time to refine those heuristics led to even better performance.
So the longer it had to learn.
The longer the LLM had to learn and adapt its strategies, the better it got at planning.
The LLMs are becoming more expert planners over time.
It's like, with practice, they're getting better.
Makes you wonder how far we can push their abilities.
It really does make you think about the limits of what LLMs can learn, you know?
Definitely.
These results are all super promising.
They are.
But I know the deep dive also covers some of the limitations of this approach.
Oh, right.
I mean, no technology is perfect, right?
Of course not.
So while Auto HD offers these significant advancements in LLM planning,
Yeah,
the research also points out some areas where there's still room for improvement.
that makes sense.
Okay, so what are some of the key limitations? What are the challenges that the researchers identified?
Well, one of the biggest things to keep in mind is that Auto HD still relies on the LLM's ability to do certain things correctly,
Like what?
like accurately generate actions,
Access.
the steps in the plan,
Yeah.
and then predict the effects of those actions in the environment.
So even with these great heuristics guiding the planning process,
Even then,
if the LLM doesn't understand the basic actions it can take,
or how those actions will change things.
the whole plan could fall apart.
It could, yeah. It's like having a brilliant strategist who comes up with amazing plans.
But those plans won't work if they don't understand the rules of the game.
Exactly. The LLM needs to understand the physics of the problem.
So it's not enough for the LLM to just be good at planning.
Right.
It also needs to have a solid understanding of the domain it's operating in.
Yeah, like the specific actions it can take and how those actions will impact the environment.
So it's not just about being smart, it's about being grounded in reality.
You could say that.
And the paper points out that we need more research to improve LLM's ability to accurately model actions and state transitions.
To understand how their actions change things.
It's like you can have the best navigation app in the world,
Right.
but it's not going to get you to your destination if the map data is wrong.
Good point.
And that's why this research is so important. It's not just highlighting the exciting progress we've made in LLM planning.
Right.
It's also pointing out the areas where we need to focus our attention.
To make these systems even more robust and reliable.
Exactly. So we've talked about the strengths, we've talked about the limitations.
Yeah.
What about the bigger picture?
What do you mean?
Where does this research fit into the whole landscape of AI development?
That's a great question.
I mean, this is a big deal, right?
It is. This research is a significant step forward
In terms of
in our quest to make AI systems more capable and trustworthy.
capable, I get that. But how does it make them more trustworthy?
Well, think about it. By tapping into LLM's ability to generate these interpretable heuristics,
Yeah.
we're essentially giving them the tools to plan more effectively
Yeah.
and to explain their reasoning in a way that we can understand.
Oh, I see. So it's not just about them being smart.
Right.
It's about us being able to understand their decisions.
That's crucial if we want to build AI systems that people can truly trust and collaborate with.
It's not just about creating intelligent machines.
It's about creating machines that we can work with as partners.
Partners, I like that.
This research moves us closer to that vision of AI.
As a collaborative force.
Exactly, and not just some mysterious black box.
And the fact that we can now see the logic behind the LLM's plans, thanks to those Python heuristics, that's a huge win for transparency and trust in AI.
Absolutely.
It's like, imagine you're using a navigation app,
Okay.
but it doesn't just tell you which route to take. It shows you why.
Why it chose that route.
Exactly. It would make you feel much more confident in the app's guidance.
Oh,
right?
definite.
And that same principle applies to AI systems in general. The more we understand how they're making decisions, the more trust we'll have in their abilities.
Auto HD takes a big step in that direction.
By making the LLM's reasoning process more transparent.
Exactly.
So for our listeners out there who might be wondering, okay, this all sounds really cool, but how will it actually affect my life?
Yeah.
What are some of the potential real-world applications of this research.
Well, imagine AI assistants that can help you plan your day, optimize your travel routes, manage your finances, even design complex engineering projects.
And they can explain their reasoning so you actually understand what they're doing.
All while explaining it in a way you can easily understand.
So it's not just about having AI that can solve problems.
There's more to it.
It's about having AI that can solve problems and then explain its solutions in a way that makes sense to us.
That's how we get real collaboration between humans and AI.
Collaboration, that's the key.
And the applications go way beyond personal assistance.
Like what?
Think robotics, healthcare, logistics, scientific research.
So this could be used in a lot of different fields.
It could revolutionize them.
You could have robots that can plan and execute complex tasks in tough environments
Or AI systems helping doctors create personalized treatment plans.
based on a patient's individual needs.
That's right.
It's pretty mind-boggling when you think about it.
It is.
And that's what makes this research so exciting. It's not just about incremental improvements.
It's about something bigger.
It's about fundamentally changing how we think about AI
And its potential.
and its potential to solve real-world problems in a way that benefits everyone.
Benefits everyone, yeah.
So as you go about your day-to-day, think about all the complex decisions you make, the plans you create, the challenges you face.
Okay.
What if you had an AI partner that could not only help you solve those problems,
But also explain its reasoning.
but also explain its reasoning in a clear and understandable way?
That would be amazing.
That's the future this research is pointing us towards.
A future where AI is not just intelligent, transparent, trustworthy, and a true partner in problem solving.
It's been a fascinating deep dive into the world of LLMs and their evolving ability to plan and reason.
It has.
Thanks for joining us on this journey, and until next time, keep exploring, keep learning, and keep those questions coming. It really does make you think, are these LLMs just like really good at pattern recognition? Or are they actually starting to understand the concepts behind the code they're generating?
That's a question that's keeping a lot of researchers up at night.
I bet.
On the one hand, it's just incredible to see these LLMs churning out functional Python code.
And it's not just random code.
No. This is code that captures complex logic. It's really impressive.
It speaks to their ability to learn from these massive data sets.
Right, and then apply that knowledge to solve completely new problems.
It's like they've absorbed all this information about coding,
Yeah.
and now they can use it to essentially program themselves to tackle these new challenges.
It's a powerful idea.
It is.
But there's still this debate
About
whether this code generation is really a sign of true understanding.
or just a super sophisticated form of pattern matching.
It's hard to say for sure.
It's kind of like that classic philosophical question.
Oh, yeah.
Like, if a parrot can recite Shakespeare, does it actually understand the meaning of the words?
That's a perfect analogy.
What?
And just like with the parrot, the answer might depend on how we define understanding in the first place.
It's deep stuff.
It gets philosophical pretty quickly.
But even if we just, set aside that whole philosophical debate for a minute,
Okay.
the practical implications of this research are huge.
Absolutely.
The fact that LLMs can generate this code for their own heuristics,
Yeah.
that's a major step forward, both in terms of their planning abilities
Right.
and our ability to understand how they're making decisions.
It's a win-win.
It's like, imagine you're using a navigation app,
Okay.
but it doesn't just tell you which route to take.
It gives you the reasoning behind it.
Exactly. It's like, take this route because there's less traffic, or this way avoids tolls.
It makes you trust the app more.
You'd feel much more confident in the app's guidance.
For sure.
And that same principle applies to AI systems in general.
Absolutely. The more we understand how they're making decisions,
Yeah.
the more trust we'll have in them.
And AutoHD, it takes a big step in that direction.
By making the LLM's reasoning process more transparent.
Transparency is key.
It is.
So, for our listener out there who might be thinking, okay, this is all really cool, but how does this actually affect me?
The so what question.
Right. What are some of the real-world applications of this research?
Well, imagine AI assistants that can help you plan your day,
Oh, yeah.
optimize your travel routes, manage your finances, even design complex engineering projects,
And they can explain it all to you.
all while explaining their reasoning in a way that makes sense to you.
So it's not just about having AI that's smart.
There's more to it.
It's about having AI that we can understand.
That's the foundation of true collaboration between humans and AI.
Collaboration, that's what it's all about.
And these applications, they go way beyond personal assistance, too.
Oh, where else?
This technology could revolutionize fields like robotics, healthcare, logistics, scientific research, you name it.
Wow. So we could have robots that can plan and execute complex tasks
Uh,
in really challenging environments
Exactly, or AI systems that can help doctors develop personalized treatment plans.
based on a patient's specific needs. That's amazing.
The possibilities are endless.
It's really mind-blowing.
It is. And that's what makes this research so exciting.
Yeah.
It's not just about small improvements here and there.
It's about changing the game completely
It's about fundamentally changing how we think about AI
and how it can be used.
and its potential to solve real-world problems in a way that benefits everyone.
So think about your day-to-day life, all those decisions you make, the plans you create, the challenges you face. What if you had an AI partner that could not only help you solve those problems, but also explain its reasoning?
That's the dream.
That's the future this research is pointing us towards.
A future where AI is not just intelligent, but also transparent, trustworthy, and a true partner in problem solving.
Well said. It's been a fascinating deep dive into the world of LLMs and their incredible ability to plan and reason.
I agree.
Thanks for joining us, and until next time, keep exploring, keep learning, and keep those questions coming.